Hi, welcome to my video on relating the x-intercepts to the zeros to the roots. Polynomials. Note the p of x is equal to the y. I have three columns here. Column A, column B, column C. In column A, I have the p of x is x minus 1 times x minus 3. In column B, I have y equals x minus 1, x minus 3. Column C, I have x minus 1 times x minus 3 equals 0. So notice the three columns have x minus 1, x minus 3 in each. But when you have the p of x, you have the function notation, p of x. The ordered pair is x comma p of x. If the p of x equals 0, the x values are the zeros of the polynomial. The zeros of the polynomial p of x, x minus 1 times x minus 3, are 1 and 3. You let x minus 1 equals 0 and you solve and get a 1. You let x minus 3 equals 0 and you get 3. The p of x equals 0. X minus 1, x minus 3 equals 0. So you let x minus 1 equals 0, you get x equals 1. X minus 3 equals 0, you get x equals 3. Again, x equals the p of x as an ordered pair. So when you have x equals 1, you have the p of 1. And when x equals 1, the p of 1 equals 0. So the ordered pair is 1, 0. And again, for x equals 3, x is 3, the p of 3 becomes 3 comma 0, because the p of 3 is equal to 0 from right here. Note, the p of 1 equals 0, and the p of 3 equals 0. 1 and 3 are the zeros, because they are the values of x that make the p of x equal to 0. On a graph, the p of x is the y. X, this is the x horizontal axis, and the p of x is the y. So the zeros are 1 and 3. So we plot those zeros, and that's, as you can see, coming up. Now let's go down through y equals x minus 1 times x minus 3. The ordered pair is x comma y. If y equals 0, the x values are the x-intercepts of the graph. Notice we have x and y, so when you have y equals 0, you're solving for x, and you have the x-intercepts. The x-intercepts of y equals x minus 1, x minus 3 are 1 and 3. Y equals 0, we let y equal 0, we have x minus 1, x minus 3 is equal to 0, so you're going through the same scenario as right here, the same idea. They are identical. You let x minus 1 equals 0, x minus 3 equals 0, solve, x is 1, x is 3. Now we have an ordered pair called xy. So when x is 1, y is 0. When x is 3, y is 0, same as these. And in the graph, we have x is the horizontal and y is the vertical. And the x-intercepts are 1, 0, 3, 0, 1, and 3. Same as here. Notice, over here we have a polynomial p of x. Over here we have a y. But they are the same, except that in terms of a polynomial, p of x equals 0, we get the zeros of a polynomial. When y equals 0 in this equation, we get the x-intercepts of the graph. And in the third column, we have x minus 1 times x minus 3 equals 0. We're solving an equation. This is the equation that when we let y equal 0 or we let the p of x equal 0. It's the same, it's very similar. So the x values are the roots or the solutions of the equation. So if you're given this equation like this and you want to solve it, then the x values are the roots or the solutions of the equation. So we're going through the same idea again right here that we did with these 2. And now when we solve these two, making x minus 1 equals 0, x minus 3 is equal to 0, we get x is 1, x is 3. Now, because we solved the equation, we have the roots are 1 and 3, or the solution, whatever way you want to say it. So, to sum it up, they're very similar. So let's sum it up. P of x equals x minus 1 times x minus 3. Y equals x minus 1 times x minus 3. X minus 1, x minus 3 equals 0. 3 different. They are all similar, but expressed differently. So in A, right here, the P of x is a function notation. The values of x which makes the P of x equal to 0 are the zeros of the polynomial. So when you see the P of x, the f of x, the g of x, the h of x, we have the zeros of a polynomial. When we have an equation in terms of y equals x, the values of x when y equals 0 are the x-intercepts of a graph. So when we let y equals 0 here, we will get the x-intercepts of a graph when y is 0. And when we have this equation like this, the values of x are the roots of the equation. So 3 different types. We have the zeros of a polynomial with a p of x, f of x. We have the x-intercepts of a graph when you have the equation like this, when y is equal to 0. Or we have this equation equal to 0, we are getting the roots. So, terminology. Match column A with column B. Here's column A with the equations. Column B have these. So, if you have this equation, we have y equals the 3 equations, the 3 parts here. See it? This part, same as this, the same as this, they're all the same. So we have this equation. Do we have negative 1 and 4 are the zeros, the roots of the intercepts? Because we have this equation, we have, this is A. These are the x-intercepts of this equation. When we let y equal 0, we get the x-intercepts. Right here, we got a polynomial. So this is, right here, this is, I said A. These are, let's label these as 1, 2, and 3. And x-intercepts are number, let's name them 1, 2, and 3. Number 1. Polynomial are the zeros. So this is number 2 here. So if you have this equation, here are the zeros of this polynomial. And number 3, what's left over, we're solving the equation, so these are the roots. Oops, I put a 3 in, and I marked in a 4 now. Those are the little errors that I make. So again, the x-intercepts are belong to this equation. The zeros are belong to this equation, and the roots are belong to this equation. Notice these answers here are all the same as the terminology. Okay, this true or false, and if false, excuse me, correct it. The x-intercepts of the p of x is, of this equation, negative 2, x minus 1, x plus 6, and the x-intercepts are 0, 1. So these numbers here fit this equation, but because this is a polynomial, these are not the 0. These are not the x-intercepts. So this is false. And to correct it, we have to put the word zeros right here. The zeros of this polynomial are these numbers. The roots of this equation are 4, negative 2, and 3. This equation equals to 0, so they are the roots. They're not the zeros or the intercepts, x-intercepts. But the 4, 2, and negative 1 is, this is a negative 4. This is a 2, and this is a 3. They're opposite signs because we let x plus 4 equal to 0 and solve it. So we're getting the opposite. X minus 2 equals 0, and we solve it. X minus 3 is equal to 0, and we solve it for x. So the zeros are the opposite of these, because when we let them equal to 0, we move it to the right side and we change the sign. So the zeros So this is a false statement as it is right now, and to correct it, we have to put the opposite to these numbers in. The x-intercepts of this graph, the x-intercepts is the correct terminology. This is the equation, they're x-intercepts. The x-intercepts are opposite of this, -3 and a 4. So this is a true statement, because when you let x minus 3 equals 0, you get a -3. When you let x minus 4 equals 0, you get x equals 4. And notice the x-intercepts is when you let y equal to 0. So this equation becomes equal to 0. And as a result of being equal to 0, each of the products are equal to 0, each of the factors. Number 4, the zeros of f of x of negative x plus 1 cubed, x minus 6 squared, are -1 multiplicity of 3, and 6 with a multiplicity of 2. So the zeros of a polynomial, that's correct. And we have -1 opposite, x plus 1 equals 0, so x is -1, that's correct. And we got x minus 6 equals 0, so x is 6, so that's correct. And the multiplicity of 3, so the multiplicity of 3 is the power, so that's correct. Multiplicity of 2 is the square, so this is a true statement as you see it. Number 5, a graph is tangent at x minus 3. Its equation has x plus 3 cubed. Well, a couple of ways we can correct it. If it's tangent, if a graph is tangent at x minus 3, which is right here, now it makes no difference if it goes up or if it goes down at the -3. We're not discussing which way is opening. This is a positive opening up. This is a negative opening down. And we're not discussing if it's curling like this or if it's curling like this. It makes no difference. We're just talking about being tangent at the -3 right there. So if it's tangent A, if that's tangent at x minus 3, this is an x plus 3. That's correct. It's opposite. But because it's tangent, it's going to be an x plus 3 squared. So it's a false statement, and we corrected it by making the cube to a square because it's tangent. It's a parabola. And if we had a cube at -3, a cube would have been a sideways S like this at -3. Or it would have gone the other way, going down, coming up like this at -3. So x plus 3 cubed. The cube is a sideways S at the point of x-intercept. But this is a square because it's tangent. Okay, let's continue. And just to finish it off, find the zeros. We find the zeros of a polynomial. So the zeros of a polynomial are the values that make the f of x equal to 0. And those values are -4, -1, and 2. So we make each of these equal to 0 and solve them. We get these zeros. The zeros of this one, we have an x here, so when we have, again, we make the g of x equal to 0, so we make this equation equal to 0. So we have an x, so we have a 0 here, we have a -7 here, we have a 3 right here, and we have a 4 right here. And that's the zeros of this polynomial. And we have next the x-intercepts of each. So the x-intercepts are the values that make y equal to 0. So you make this equation equal to 0. So the zeros are, the x-intercepts of this. This is the equation y equals x. So it's x-intercepts. I'm saying zeros as if we're doing polynomials. This is the x-intercepts. The x-intercepts are the opposite, -6 and 1 and 5. So if you put -6 in here, 0 times whatever this is will give you y 0. Put 1 in here, multiply 0 times these two, you'll get y 0. Put 5 in. And even though these are the x-intercepts, there's a multiplicity of 3, so there's a sideways s. But the x-intercepts, there's 1, 2, 3 of them. There they are. And the x-intercepts of number 2 is when you let, again, y equals 0. This equation becomes equal to 0, so x is 0 here, negative 3 here, and 6 here. So the intercepts are 0, negative 3, and 6. And we said find the roots of each equation. And the roots are when you have an equation equal to 0. The roots are the values of x which make the equation equal to 0. So that's a negative 2, 3, and a 9. They're the opposite. So we make each binomial equal to 0 and solve. So we get negative 2, 3, 9. And number 2, the roots of this equation, when you have it equal to 0, the roots are negative 4, 1, and 10. Again, if you put negative 4 right here, no matter what we have here, 0 square root is 0, and 0 times these numbers will give you a 0. And so the roots and this root, again, the multiplicity is only needed when you're looking at a graph. So the roots are negative 4, 1, and 10. But if you're looking at a graph with a multiplicity of 2, that at negative 4, the graph will be bouncing off. And at 1, it would be sideways S. And at 10, it would be a line going on through. But the roots are just the values of x which make the brackets equal to 0. Negative 4, 1, and 10. Okay, that's explaining the x-intercepts, the zeros, and the roots in terms of how the equation is stated. And if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content of my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.